Hello everyone, this is Bohan Zhang from BUCS 506. This is my final project report. First of all, I will give a brief introduction of dataset of the project. My data was come from Kaggle. You can see the link in the README file, and the author gave two original dataset, which is the fake CSV and true CSV, which is real news and fake news. If you download the original data of the real news, you can see there's 4 columns, which is title, text, subject, and date. We're gonna only use the text as input for our model. It's an NLP project, and if you open the fake news dataset, you can see the structure was absolutely same as the real news. So what the first steps do here was combining the two datasets for training purpose, and after we're combining, we're gonna shuffle the datasets due to we don't want a model be lazy. Like if model just simply predicts the first half is real and second half is fake, even though get very high accuracy, we don't want to see that. So after this, we have a new dataset which named news.csv. As you can see, this is very big dataset, which is about 45K. The dataset was too big for a NLP project. It's very computationally expensive. So what we're gonna do in the next couple of cells, we're gonna only pick about 10K for training purpose. And as you can see, the second cells here is checks the length of the token after tokenization. What the purpose of doing this have two reasons. The mainly difference between there's a two good option for this model, which is the DCL BERT and classical BERT. The main difference between them is the classical one have very good prediction, but is very computationally expensive. The DCL BERT, which is a live weighting version of the classical one, but have 60% of only 60% of computational time, and it could reach about 96 or 97% of accuracy. So we can see the average of the token length is about 510. The limitation of the classical one was 768, and the DCL BERT one was 512. The number of the token lengths is reasonable for our to choose. The DCL BERT is computational faster than the classical one. The everything of this project next was doing by the DCL BERT, and for this cells, we are trying to test the function of the dividing the training set and test set is working properly, and you can see it could divide the 45K in a very good way, and which means our 10K dataset could divide properly after this. And what I did for this cell is visualization by doing a word cloud for see what's the highest accuracy word in real news and what's the highest frequency word in the fake news. I pick 50 words here. You can see there's a lot of the same words appears in two clouds, but we're not worried about this because the BERT have the have the model of the transformer, which means the model could see the context of the word, which helps the model to prediction correctly, even though have the same word. So this is the training cells here. We only pick 10K here, as you can see. And after this, we have some hyperparameters, which is I set the batch sets of eight data set as batch, and set approach of the 5. We probably not gonna use all of them because I said early stop here. If it reach the local optimal, it's gonna stop. The model gonna stop and pick the highest accuracy one as a final parameter for the test set. So you can see we not use five of them. We only use 3. And when we're doing the third approach, the accuracy will stop to increase. So we pick the third parameter set for testing set prediction, and you can see I visualization my results. The accuracy was pretty close to 1, but the prediction result was too good. We don't know if the model was too powerful or it's overfitting. So I have some extra experiment for see if it's overfitting or not. So as you can see, for every approach here, the loss curve is very different. For the first approach here is the final. On the final, is a little bit increasing, and same as the second one. But for the third approach, the curve is flat and is remain at 0. So that's why we pick the third as the final parameter to prediction our test set. But we still don't know it's overfitting or not. So our visualization, the output of the softmax function, you can see in the image the number was very close to 1, which means the model was very confident to our prediction, and that's still not enough to say our model is not overfitting. So I change another dataset. You can see I change another random seed. I'm not doing this once. I'm doing this 5 times, and every single time use the parameter of the approach 3, our model was doing pretty well. You can see the accuracy was very close to 1, and F1 score and recall precision also can state that our model is not overfitting, is very good. The parameter finds a local optimal, which is our model was powerful enough to predict. To my curiosity, I do some extra experiment here is to see if I delete the first sentence of the text, if the model could still properly classification the real and the fake news. Surprisingly, the model was doing a little bit not that good. I guess the reason why is because the transformer makes a model to see the context, but the model could only see the second sentence of the text. The model don't know where the information comes from. So the model was confusing by the information. As you can see, the fake news still predict as fake news. There's 0 of them predict as the real news, but some real news being predicted as fake news since the context error. The context missing, and even though the model was even more confidence for our output. So that's helped me better understanding how the model was working. For the requirements, I put all the requirements in the requirement.txt. But don't worry, that I made all of them could be installed in the makefile. There's 2 makefile. One, the first one, the makefile, is for macOS, and the second one was for Windows. The install portion gonna help you to install all the requirements, and if you try to run the model, it's gonna take about 3 hours, even though it's a 10K dataset. but I have a test model.py here. If you input a very dummy input here, the model could still output um, a structure of the output here, which means the model structure is proper. And that's my final report. Thanks for watching.